record. Okay, so we're doing more U substitution. So we're going to do a couple examples. I've got some board problems for you to practice, and then that's all. So U substitution, remember we start by picking a U, finding its derivative, substituting, integrating, substituting. Yeah, so pick a U, find its derivative. And we said we should pick our U's how? Do you remember how we suggested picking U's? Inside functions. So things that are raised to powers, things that are under square roots, things that are in denominators, and then sine, cosine, exponentials. Okay, so here's my first example. Sine x e to the cosine x dx. What do you suggest I should pick for my U in this first example? Yeah, let's pick U to be cosine x. Okay, what's the derivative of cosine? Negative sine. Okay, do I have everything I need here? I'm going to rewrite this and I'm going to put the sine at the end with the dx. Do I have everything I need? I need a negative, right? I need this negative. So if I put a negative inside here, what do I have to put in the front? A negative, right? I want to keep the integral the same. So, and remember, you can only substitute in, you can only stick in numbers. So I stuck in a -1 in the inside, which means I have to put a -1 in the outside. So this guy, cosine x, is my U. This guy, negative sine x dx, is my du. So this integral looks like negative e to the u du. Oh, what's the antiderivative of e to the u? E to the u. Plus c. Okay, I started with x's, I should end with x's. So what do I have to do? Plug in. Yeah, what goes in here for you? Cosine x. Okay, so negative e to the cosine x plus c. Okay, let's try again. Cosine of 2x plus 1 dx. What do you want to pick for your u?
2x plus 1.
Yeah, stuff inside the cosine. 2x plus 1. Great. U equals 2x plus 1. Okay, derivative of 2x plus 1 is 2. The derivative of 2x plus 1 is 2 dx. Do I have everything I need? I need a 2 there, yeah? If I put a 2 on the inside, I have to put a 1/2 in the front. When I put a 2 on the inside, I have to put a 1/2 in the front. Okay, so that's my u. This stuff here is all part of my du. So I have 1/2 integral cosine u du. Okay, antiderivative of cosine? So close. Positive sign. Plus c. I started with x's, so I should end with x's.
So for the du equals 2 dx, could you just say du over 2 and then just replace that with dx?
You sure can. So remember on Monday, I talked about there's 2 schools of thought. You can stick in what you need or you can substitute and solve. I don't like the substitute and solving because then you mix u's and x's together. And I never like mixing u's and x's together because I'm afraid like things won't cancel and it'll go bad.
But wouldn't you be able to replace the 2x plus 1 with the u? So then you would, in this sense, so there may be other scenarios where we are.
Yeah, so let's talk about it again when I get to this one. Okay, because so what Adrian suggested is we could solve for dx here and write it as du over 2. And then here, write du over 2 cosine u. And then that 1/2 will come in the front because I have divided by 2. Yeah, but down here when we see different things. I mean, I guess we could talk about it with this one. Let me get a blank paper. was it sine x e the cosine x dx? So if I let u be cosine x, then du is negative sine x. Oops. This is the same problem we just did. Dx. So one school of thought is solve for dx. Dx is going to be du over negative sine x. Yeah. So then here, cosine x is u. So I'm going to write u there. And then I'm going to take this guy and substitute him for dx. Whoops, too far. So what I have is sine x e to the u times du over negative sine x. And you see how like I have x's and u's mixed together? And yes, these signs are going to cancel and you're left with a -1. But the problem is that if you do it this way and things don't cancel, you have a tendency to just be like, oh, it didn't cancel. I'm just going to integrate with x's and u's. And that's like really bad news. So that's why I tend not to do it that way. But it should work out fine.
So when does it not work out fine?
It doesn't work out fine if like you pick your u badly.
Okay.
Yeah, but the problem is like, if you do it this way and you get things that have x's and u's left here, then people just have a tendency to just integrate anyways and not think like, oh, I screwed up, right? So that's why I don't like to do it that way. But you can, it's not, you know, wrong per se. Okay, we were almost done with this guy. What's the last step to finish this guy here? What'd you say? I didn't hear you. Plug in u, yeah. So plug in 2x plus 1 for u there. So 1/2 sine 2x plus 1 plus c. Okay, so take a second and think about these two and just think about what you're going to pick for u. So don't tell me yet. Just think about these two questions and tell me what you think you're going to pick for your u in these two questions. Is everybody ready? You have your plan? Almost. The first one should be easy. The second one you might have to think a little bit harder. So what'd you pick for u in the first one? 3x inside the thing there. Okay, how about in the second one? Yeah, denominators, 4 minus e to the x. Okay, let's do the second one first. I think it's easier. If u is 4 minus e to the x, then the derivative of that is negative e to the x dx. Yeah, derivative of e to the x is e to the x. It's negative because I have that negative sign here. So I need a negative in here. If I put a negative on the inside, I need a negative on the outside. So I would write this guy as negative 1 over 4 minus e to the x times negative e to the x dx, because now it's easy for me to see that this part is my du and this part is my u. So this guy's going to look like negative 1 over u du. Do you know the antiderivative of 1 over u? ln, yeah, ln u plus c. I started with x's, I should end with x's. ln 4 minus e to the x plus c. I got my booster today and my arm's starting to hurt already.
How do you get 1 over u?
I pulled that e out to the end. Yeah, like right, let me scroll up a little bit. I rewrote this fraction here, e to the x over 4 minus e to the x, as 1 over 4 minus e to the x times e to the x. That way I can kind of see the numerator part went to my du, and this would leave me with 1 over u there. Okay, how about this guy? Do you know the antiderivative of cotangent of u? I see people like looking back through their notes, like, what's the antiderivative of cotangent of u? That's the derivative. What's the antiderivative? I don't know it. Man,
That's not my sheet.
is it on the sheet?
I don't think so.
It's not even on the sheet, right? Shoot, this is not a good choice for you. Dang, it doesn't help me, right? Like if you pick your u and what's left is something you still don't know the antiderivative of, then you've chosen badly. Okay, start over. Red X this one. Bam, bad. Okay, can you change cotangent into a fraction somehow? Yeah, cosine over sine, right? Cotangent is the same as cosine over sine. So I'm going to rewrite cotangent as cosine of 3x over sine of 3x. Yeah? Are we okay with that? I'm actually going to rewrite it as 1 over sine of 3x times cosine of 3x. Same trick I played over here. Now, what would you pick to be your u? Yeah, the denominator, right? Let's pick our denominator to be u. U is going to be sine of 3x. This guy here. Okay, what is the derivative of the sine of 3x? So close. Positive was good. Cosine 3x.
Oh, times 3.
Times 3. You need to use the chain rule, right? The derivative of sine is cosine. Leave the inside alone. Multiply by the derivative of the inside. So the derivative of sine of 3x is cosine of 3x times 3 dx. All right, what's missing? 3. If I stick 3 in here, I have to put 1/3 in the front. Okay. So this guy is my du. Okay, here we go. 1/3. What does the inside of my integral look like? One over u times du. Perfect. 1 over u times du. Okay, antiderivative of 1 over u. ln, awesome. Natural log of u plus c. I started with x's, I should end with x's. 1/3 natural log. U was sine of 3x plus c. Okay, we're going to do some board problems, which require you to make groups of 2. Let's make groups of 2. So everybody find a group of 2. I'm going to decide which one I don't want to do. I'm going to leave that one out. Everybody have, are you guys going to be a group? Tatiana, did you pick a group? No. All the way in the back, Luis, raise your hand. He's going to be in your group. You're going to like it, I promise. Okay, everybody has a group of 2? Okay. Oh, let me stop the recording.